Okay, 2.3, proving theorems is our topic today. First theorem we're going to be proving is called midpoint theorem. So let me show you where, here you go. So write this down. Okay, and it says if, we like this because it's got name on it, right? Isn't that nice? If M is the midpoint of AB, segment AB, then AM equals to half of AB and MB is equal to half of AB. You guys remember when we write these things without the symbol on top, the segment symbol, what's that mean? This is the? Exactly. The length of AM is half of the length of AB, and length of MB is half of length of AB. And here's the picture. And kind of interesting thing to note, sometimes we don't give you given and prove. We just give you this sort of statement and we ask you to prove it. And kind of interesting, look at what's given. M is the midpoint of AB, right? Look at this conditional statement. Which part of this conditional statement is the given part? Hypothesis or the conclusion? Yes, sir. Hypothesis. Guess what the part that we will have to prove is? Yeah, is the conclusion is correct. Okay. So kind of note that this is going to be true if you have a conditional statement. Right. So sometimes they don't give you this. Okay, they just say they give you this statement. They go prove it. And now, then how do you know which part is the given part and which one's the part that you have to prove? It's because given part is a hypothesis. The part that you have to prove is the conclusion. Yes, sir. Question?
Did we write it down?
Yeah. Okay. Go ahead. Write it down. I'll give you time. By the way, what does this theorem sound like? Anybody? This is actually back in section 1.3. You could go back to your notes if you like, I don't mind. Look at 1.3. Read. Doesn't this sound like this theorem? Doesn't it sound similar to what we sort of studied? Brandon, does it sound similar to something? Not really? Okay. Go to like 1. Oh, some of you went back. Tony, what do you think? Segmented, yes, it does sort of sound like segmentation postulate, but this is sort of a special case, right? You have the point in the middle. Segmentation postulate does not require that you have a midpoint, right? Okay, not only that, like look at your 1.3 notes. We sort of talked about this. We have something similar to this one. Anybody? 1.3? No one notices anything similar. We talked about, like look at this theorem. If M is, yeah. No, what I'm saying is, from 1.3, section 1.3, we sort of talked about a statement that is similar to this.
Oh.
Yes, sir.
Two lines there is exactly 1 line. 2 points.
No. Yes, sir. How about Kevin? Exactly, that's what I was looking for. You guys remember, what is that? What was that, Kevin? That was the definition of? Midpoint. What does the definition of midpoint say? It says what? It divides the segment into two congruent, not equal, congruent segments, right? Right?
Yeah.
Isn't this the same thing as that? Not really same, but it's similar. Does that make sense? So some people may make the mistake of, right, thinking that these two are the same thing. No, they're not. What does this one say? How are they different? This one says, yeah. Yeah, AM is half of the whole thing. The definition doesn't mention anything being half of anything. No. All it says is what? The definition, all it says is AM is congruent to MB. It doesn't say half of AB. Does that make sense? Do you guys see the difference? There's a subtle difference there. Okay? Yeah? So this theorem is actually saying similar to what the definition of midpoint is saying, because all the midpoint definition says is AM is what? Congruent to MB. This is being a little bit more specific, right? Even though in our head it sort of seems the same, right? But it's saying AM is what? Half of the whole segment. Also MB is half of the whole segment if M is the midpoint. Does that make sense? Do you see how? So let's summarize this. Can somebody read the theorem uses definition? How about here? Oh, I'm sorry. Let me, please. Here. Can somebody read this part? The theorem uses the definition of. Who would like to read that part for us? Go ahead, sir.
Theorem uses the definition of a midpoint to prove additional properties of a midpoint. are not explicitly included in the definition.
Exactly. This theorem uses definition of midpoint to prove it, but right, it has things that are not explicitly included in the definition, right? Even though it sounds sort of similar, right? Does that make sense? So this theorem is not so basically what I want you to understand, what I want you to get out of this is this theorem, even though it sounds similar to the definition, it is a little bit different, okay? It is saying that AM is half of the whole thing, or MB is half of the whole segment, if M is a midpoint. Does that make sense? Okay, do you see the difference? So in other words, like on the homework or on the test, right, if you want to state that AM is half of AB, would you use the theorem or the definition? Theorem. But if you want to say AM is congruent to MB, would you like to use the theorem? Would you use the theorem or the definition? Definition. You see the difference? You get that? Okay, there's a subtle difference there. Okay, don't use interchangeably, then you get it wrong. All right, so let's go ahead and prove this thing. So I'm really nice. I'm going to give you the first line for you. Here, given. M is the midpoint of AB. Okay. Now we want to prove this so that at the end we want to say AM is half of AB and MB is equal to half of AB. So after this, what sort of comes naturally after this? Saying M is midpoint. Yes, sir. MA
equal to NB.
Yeah, MA is equal to MB. Well, you kind of have to say they're congruent, right? The segment AM is congruent to segment MB. Why? What's the reason? Definition of midpoint is exactly right. So since we said M is the definition, since M is the midpoint, we're just going to use the definition of midpoint and say AM is.
What's the reason?
What's the reason? Is because definition of midpoint. By the way, something is sort of odd here. How is it that they could just now all of a sudden sort of stick this in right here? AM equal to MB. Because doesn't the definition say the two segments are congruent? They don't say their length are same, right? Tony?
Well, if they're congruent, which means that their length is same, and then you could just...
Exactly right. They're sort of using the definition of congruence, right? If two things are congruent, what does it mean? They have the same measurement. So they're kind of using that together. Okay? So if they were really being careful, guess what? They should have written this as the third step, right? And write what would the reason be? Because this is what I want you to do on your homework. Okay? They're not being really careful here. They should have written this as a third step after saying that AM is congruent to MB, because that's what the definition says, right? It doesn't say anything about them having the equal measure. They just say the two segments are congruent, right? Isn't that what the definition says? But and then as a third step, you will write this. And what will your reason? What will your reason be? We talked about it. Yeah.
They have equal length.
No. Yeah. Definition of congruence, right? Definition. If two things are congruent, we know that they have the same measure, right? So in this case, they sort of put it together. But if you're being careful, and this is what I want you to do also in the test and the homework, I want you to separate them. Is that okay? Are we good there? Okay, because I don't want you to be thinking, oh, where did they get that from? That's because of definition of congruence. They sort of put it together. They shouldn't have. Okay. Anyway, after that, okay, that's great. But we don't have what we wanted to say, right? We want to say that AM is the whole half of the whole thing, MB is half of the whole thing. So far, have we said anything about AB at all? Do you think we have to sort of mention AB somehow if you want to sort of make it equal to each other? Right? So anybody know how we could sort of state something about AB and so forth? 1, 2, 3, 4, 5 people see it. Okay. Nicholas, what do you think, sir?
AM plus MB equals AB.
Exactly. Those of you that your hand up, how many people had that thought also? Very good, right? Doesn't that make sense? We want to say something about AB, right? Even though it's not half of AB, still it's AB, right? It's better than nothing, right? So we say then, if you add those two segments, the length of those segments, it's the whole thing, right? Justin, what's the reason? Exactly right. Segment addition postulate. Now we're getting somewhere. Isn't this nice? So we have like AB. We like that because we have to say something about AB, even though it's not half of it. But that's okay. How do you make something? Like if you have AB, how do you make half of AB? Divide both sides by?
2.
Yeah, 2. Then that's not a problem. You could get half. That's easy. Okay, so what do we do next here? Anybody see what we could do next? I want you to actually think about it as a group. Go ahead. Discuss with your group. What do you think we should do next? How are we going to get to that last statement? All right. Anybody know what to do here? Hannah, what do you think? What did you guys come up with? 2A. Okay. How did you get that?
Because AM equals to MB.
Exactly. Look at the second step. Didn't we just say AM was equal to MB? Well, in place of MB, guess what we're going to substitute in? Not 2, but in place of AM. And of course, when you add AM plus AM, don't you get 2 AM? Yes? Okay. So, what's the reason for the first step? Yes, sir? That's exactly right. Substitution what? Property. By the way, we mentioned this also, right? For substitution, substitution is only used for numerical value. Okay? So that's why I now know why we had that substitution with all the equalities, right? Substitution is only used for equalities, not for congruence. Please remember that, okay? So you may not substitute for congruence, okay? That'd be wrong. Substitution is only used for, again, what? Equality, meaning some numerical value. Does that make sense? Some numbers. Okay, that's only used. Yes.
Yeah, isn't it addition?
Okay, hold on. So first of all, do you agree that in place of MB, we could plug in AM here? Is that substitution? Now, they're saying this is also substitution because they put it in the same step, right? Yeah, what's AM plus AM? 2 AM. Do they have same value? AM plus AM, is that equal to 2 AM? That's another substitution. Okay. You may think addition, but we don't have any addition property or anything like that, do we? We have addition property of equality. Have you added same thing to both sides? No, that's not what's happening. Yes?
AM plus AM equals AB and then the next step 2 AM.
Yes, and then what would the reason be if you wrote that as a second step?
Substitution.
Still substitution. That's why you see why they put them all together. You see what I mean? They had the same reason. They said, okay, let's save some space. We're going to put them all together. Are we okay? But is it okay to write them as a separate step? That's fine. Now, we like this because all we have to do is what? Divide by 2. And what's the reason? Division property of equality. Is that okay? Are we done?
No.
Not quite. We've said the first part. How do we say then the second part?
Substitution.
Okay, right. You could actually, in place of AM, what can we plug in? MB. And we're done. Okay, does that make sense? And of course the reason is because of substitution. Or you could have actually, in place of, you know how we substitute MB with AM? Could we substitute AM with MB and get the last statement? Right? You could do that. It doesn't matter. That would take you a couple more steps, but it doesn't really matter. Right? Like I said before, just like solving equation, there are many ways of doing it, okay? So as long as you do them correctly, it's fine. Are we okay? Does this make sense?
Yeah.
Any questions? Raise your hand. How many people understand? Raise your hand. Somebody has a question. Yes, sir. Good question. On the test, do we need to write these steps 2 and 3? By the way, why did they put this? Yeah, just to clarify. You don't have to do this, but this is a good practice actually, because if you want to ever go back to it, and if you're kind of confused, you don't have to read through the whole thing again, right? But are you required to do that? No. The blue things you don't have to do. It's sort of nice. Yes, Hannah. No, sorry. Okay, may I move on? All right, let's go. Okay, here's our next theorem. It is actually very similar to the one that we just did. And nice, this is sort of nice because it has, again, name, right? The second theorem we're going to talk about today is called angle bisector theorem. And there's a picture of an angle. Anybody have any guess what this angle bisector theorem might say? It'll be, like I said, it is very similar to what we just talked about. 1, 2, 3, 4, 5, 6, 7, 8, 9. How about, not of you, how about Josh? What do you think, sir? Okay, so what do you think it's going to say? If you have the angle bisector, right? Then what? Then two angles are congruent? Actually, we said that before without this theorem. We said that when we had the definition of angle bisector. Right? Just like before, when the definition says, yes, these two angles, right? They're congruent. ABX and XBC. But that's not what this theorem is going to say. Like I said, I told you it is similar to the midpoint theorem. 1, 2, 3, 4. Okay, fine. Okay, hold on. Actually, Kevin, I asked you. Oh, I haven't called Samantha. What do you think?
I think it's going to say that if ABX is the bisector,
Right.
angle ABC, then angle ABX is equal to half of angle ABC.
Yes. Exactly. What this is going to say is, this is very similar to what we just said. Samantha is correct. If bx is the angle bisector, guess what? This angle right here is half of the whole thing, and this angle right here is half of the whole thing. Just like before. Look. Does that make sense? Because we don't need to say they're congruent, because we already talked about that. That's by the definition of what? Angle? Hello? That's because of the definition of angle bisector, right? We could say these two angles are congruent, right? That's not a problem. But you see, this is saying a little bit different than the definition. It's saying this angle is half of the whole thing, just like the midpoint theorem. Does that make sense? And of course, this angle XBC is half of ABC. And again, notice what's given to you is in the hypothesis, and what you have to prove is in the conclusion. You see that? Okay, so keep that in mind. So write that down. I'll wait. Anybody need more time? Actually, we're not going to prove this here today, but the proof is really similar to the one we did in the midpoint theorem. Is that okay? So now that we talked about this, you may use this for your homework. Okay? So what theorem we talked about or we proved in class, you may use it for your homework that night. Does that make sense?
So the things we didn't learn, we can't use.
Yeah, so things we didn't learn, like in other words, you cannot use, like some of you may know some of the other theorems, right? Like side angle side, things like that. You can't use those right now, okay? Because we haven't talked about those. Does that make sense? Only ones that we talked about in class. In other words, you can't use theorems from chapter 3 or 4 for chapter 2, okay? So you can't do that, okay? So very good. All right. So like I said, we're not going to prove this, but the proof is really similar, okay? All right, here we go. So what I want to then talk about next is, even though we're not proving that previous theorem, because it's really similar to the one that we did before.
Wait, we're not proving that one?
But we are doing this one, though. Okay, so here is what's given to you. And remember, all these theorems that we studied in class, especially in that section, the more you could use, it's going to make your homework a lot shorter when you do proofs. Let me just give you a hint like that, okay? Because otherwise, anyway, okay, so let's look at example 2. It says the ray EG is a bisector of angle DEF, right here. You see this EG right here? That ray? That's the bisector of this whole angle. And then SW right here, that's the bisector of this whole angle, RST. And by the way, look at that third one here. Is that part of given, or is that what you wanted to prove? What? Look at this angle, measure of angle DEG is equal to measure of angle RST. Is that part of given, or the part you have to prove? It's part of given. Okay, just because it's on third line, okay, doesn't mean it's part of, okay, so it's part of given. So as you can see, by the tick marks there, these two angles are congruent. Is that okay?
Where's the proof?
And here, they want you to prove that measure of angle DEF, the whole angle right here, is congruent to measure of angle RST. Okay, that's what they want you to prove from this given. Okay. Yeah, we're gonna do it together. So yeah, we're gonna do it together. So go ahead and write this down. I'll wait. And as you write this down, maybe not proving it, but can you think of the reason why this is true? Like, does this make sense? Does this look obvious?
Yes.
Should this be true? If this is what's given to yes? Okay, if it is true, think about how you could explain to someone, okay? Because I'm going to ask somebody. How would you explain this to someone? This is, if these three things are given to you, this should be sort of obvious, right? Because if you could explain that, that means if you could do that, that's going to help you to prove this problem, because the process would be very similar, okay, to how you could explain this in just words. Okay, go ahead, think about it. Here we go. So, Brianna, what do you think? Does this proof make sense? What they're asking us to prove? Yeah, how? How can you explain that to us?
Angle DEG.
Right.
Angle RSW.
Right. They're congruent, aren't they? Yeah. So this angle right here is they're congruent. So.
And then the angle D.
Yeah. Take your time.
And then that's like bisecting like.
Exactly. This EG is bisecting the whole angle. Guess what? This angle is also congruent to this one. Right? And then what about this one? SW is bisector, right? So this angle right here is congruent to? Yeah. Guess what? All four angles are congruent. Let's say if this is like 20 degrees. What's this one, guys?
20.
What's this one? Because we said these are congruent, right? And what's this one?
20.
So what's the whole angle?
40.
What's the whole angle?
40.
Yeah, see? Right? So they're congruent, right? Aren't they? Right? So, right? If this is 20, they're all 20, aren't they? So this whole thing's got to be 40, this whole thing's got to be 40. So of course they're going to be congruent. And wouldn't it be great if we could just say that and then that's how you prove? No. We haven't proved it for every angles, right? We only prove for 20 degrees, right? So we have, that's kind of cool about proofs. Because by doing it this way, as we do this 2-column proofs, it actually works for every single angle that you could think of. Does that make sense? Not only for 20 degrees. Right? So, first, I'm so nice. I'm going to give you the first line here, given. All right. And look, I mean, you had a choice. I could have given you the other one on the bottom or this one. So I give you the first one. Yeah, I am very generous here. So, anybody? So can somebody think of what comes natural to us after this? If we say EG is a bisector of the whole angle and SW is the bisector of the whole angle. Yes, sir.
Angle DEG and angle G.
Exactly. Doesn't it? Like the next step should be like this angle right here is congruent to this. This angle right here is congruent to that. And later, since these are congruent, you could actually use some sort of transitive property or whatever, substitution. But they don't do it that way. You could do it that way though, it turns out. But because we just talked about the theorem, what do you know about an angle bisector? You could actually do it that way, but this makes it a little bit shorter. This is what I'm talking about. Okay. Who haven't I called? I haven't called. Yeah, I haven't called. Ye-chan, what do you think?
Angle DEG plus angle GF equals DF.
Oh, you want to say, okay, these by using angle addition postulate, you add these two angles, the whole thing, right? Actually, like I said, if you use the theorems that we use today, you don't have to do any of that. Actually, you could do it that way. But what can we do about if you know that this is an angle bisector? What do we talk about? If you have an angle bisector, what do we know? Nicole? That the two angles are congruent. That's because of the definition, right? But things that we just talked about, look at your note. What do we talk about today? Hannah, patiently waiting for it.
Angle DEG equals half of
Exactly. Don't we know that if this is an angle bisector, isn't this angle half of the whole thing? Isn't that good to say? Why? Because look, don't we want to talk about the angle DEF, the whole angle? And don't we want to talk about the whole angle RST? And by using angle bisector theorem, we are able to state something about that whole angle, even though it says half of it. But that's okay. We could get rid of that, right? We can multiply both sides by 2. That's not a problem. You understand? Okay. A lot of you may say, "Oh, do we have to use this?" No, but if you don't, turns out if you use all the stuff that you said, like, oh, this angle is congruent to this angle is congruent to that, and all, or you add these two angles, you get the whole angle. If you do that, guess what? You'll be proving the angle bisector theorem, and therefore your proofs will be a little bit longer. But is it okay?
Yeah.
That's fine. That's fine. But like I said, if you can, you should use the theorems that are described in that section. That's going to make your homework a lot easier. Okay. There's a reason why they give you these sort of things to try, okay? They want you to be able to use those theorems that we're talking about within that section. Okay, so after this, it actually once you do this, it makes things a lot easier. What do you think we're going to do next? One person? I want you to actually talk about in terms with your groups. Go ahead. Some of you know, okay. But think about it. Go ahead, talk to your group member. See if they agree. Here we go, guys. All right, now that we talked with our groups here, take a look at what we want to say. At the end, right, after all this, we want to say angle DEF is congruent to measure of angle RST, isn't that right? That whole angle is congruent to the other. Now, all we have so far is half of this whole thing, right, is congruent to, equal to this, right here, and half of this whole angle is equal to this angle. Wouldn't it be great if we could say these are congruent to each other? Half of these two? Are they?
Yes.
Now, what do we need to say then in order to say that? Dylan, what do you think, sir? Any idea? Not yet? Dylan, take a look at this. We have this whole angle, right? Half of this whole angle is equal to this angle right here. And half of this whole angle is equal to this angle right here, right? What do we know about these two angles, Dylan? They are congruent, aren't they? How do we know that? Who told us this? Who told us this? It's given, so guess what? We're going to say that first. Okay? And now, Dylan, watch this. Dylan, isn't this nice? Because if they didn't give us this given, we couldn't do this problem. Now, guess what we're going to do, Dylan? We're going to, what is DEG equal to? Look at the second step. DEG is equal to? Half of the whole thing. Hold on, guys. Right? So guess what we're going to do next, Dylan? We're going to substitute it in. Does that make sense? And why do we want to do that? Because don't we want to talk about in terms of the whole angle? Even though it's only half of it, that's okay. That's not a problem. Right? We could just talk about half of those because now we're almost done, aren't we? Would you agree that we could substitute in place of DEG half of angle DEF?
Yes.
Could we say in place of measurement angle RSW, could we put half of angle RST? Now we're almost done. Eamon, what do you think? What do we do next?
We multiply by 2.
Yeah, we multiply both sides by 2, right, Eamon? And we're done. And what's the reason that allows us to multiply both sides by 2? Multiplication property of equality. And there you have it. We're done with this proof. You see how that works out? Okay, so that's okay to have half of something, as long as we're talking about that whole angle, right? And so when you multiply both sides by 2, you get the statement that we wanted, which is angle measurement of angle DEF is equal to measurement of angle RST. Any question? Okay, still writing? That's fine. Go ahead. Any question? Now that you had some time to talk with your group members, any questions? Do you understand? Okay. Raise your hand if you understand how this proof worked out. Okay. Not all of you. Oh, okay. Does this make sense? Some of you don't have your hand up. Are you sure? Okay. Because don't worry, you get some of these for your homework tonight. Okay. So for you to try. We'll find out. Okay. Here we go. Let's go to the next. Okay. Here we go. So, what sort of reasoning have we used to do this two-column proof? Yes, sir? Deductive reasoning. We're doing these in logical sequence, right? Logical order. So, when we do these when we do this two-column proof, okay, a great example of deductive reasoning, right? What sort of things can you put on the two-column on the right side of the two-column? Yes, sir.
Reasons.
Right. So, what sort of? Yes. Okay, you could, very good. A lot of people forget this, but you could put down the given information, right, on the right side of this two-column proof, right?
Do we use this?
Will you write it?
No.
No.
You don't have to, it's in the book, but I want you to know, okay? But it's a good idea to write these. Okay, well, hold on, next. What else could go to the right side of the, yes, sir? Definitions, exactly. What else?
I know.
Yes, sir.
Theorem.
Theorems, yes.
I know.
Postulates, yes. Properties is exactly right. So write this down. Now, I'm kind of being careful here.
I said that, don't write it down.
But write it down. I changed my mind. Okay, that's important. Okay, now remember. Listen. Look at the postulates. Hello. The book's going to treat the properties that we learn in algebra as postulates. Is that okay? So we don't have to prove them. We're going to just take them as true. Is that okay? And also, guys, look. It says theorems that we already have been proved. That already have been proved in class. Or these could be theorems that we actually talked about in class and I said you could use. Is that okay? Does that make sense, guys? So if we have those, and like I said, guys, when you're doing a homework in that section, do you think those theorems that you talked about in that section is going to be useful for you to do the homework? Please keep that in mind, because otherwise you'll be proving that theorem all over again. Does that make sense? And that's a good practice. That's fine. I like that. But, just to help you out, right? You could use those theorems that we learned in that section. Okay. Any questions? Anybody need more time to write these? Okay, I'll wait. Good.